Okay, so what is a module? If you look at the wiki page, it says something about being a generalization of a vector space. So instead of a field acting on it, you now have a ring acting on it. I want to give a slightly different view of it, maybe slightly wrong too, but it's good to have this in the back of your mind, or if you're still trying to learn what a module is, this might help you. So if you have an abelian group, let's say G plus, and it's very tempting to write elements like G plus G plus G as just 3 times G. But there's a slight issue with this, namely 3 is not a group element. No, it's in fact an element of the ring of integers. And so we can say, okay, we just define an action, right? The ring of integers onto this abelian group by this, right? We just write G 3 times. But there's something more going on. If we look at the action, the ways 3 can be written in a ring, so for example 1 plus 2, it distributes nicely. And we can also see that holds for multiplication too. So for example 9G here, you can see that decomposes into 3 times 3G. You can pick 3 groups of 3Gs. And so we have this nice action of the ring of integers onto this abelian group. We have a name for that. That abelian group is called a Z module because Z has a nice action on the abelian group. Another example is, for example, for groups, if you have a normal subgroup, every element of the group acts on that normal subgroup. Same can be said for rings. If you have a ring R, an ideal, well, the ideal is absorbing. So every ring element defines an action on the ideal, and you still get back the ideal. So in that case, the ideal is an R module.